level 8. Alright, level 8, still on the right angle triangles with Pythagoras. Now we want to find an angle. Alright, so I'm just going to rotate. Here's my little rotation gesture, 2-finger gesture, rotate. So I'm going to rotate it like that. You can stretch and shrink using the pinching gestures. This is my right angle on the triangle. Directly opposite the right angle is the hypotenuse. It's the longest side. It's also the side that doesn't touch the right angle, right? So there's no right angles on this side, okay? The other two legs come into contact together at the right angle. All right, so the other two legs are perpendicular to each other. So this is my hypotenuse. So I'm just going to write hypotenuse, or height. All right, opposite of my angle that we're talking about, opposite of that is the opposite side. So I'm going to write opposite. And the leg left over has got to be the adjacent. And remember, adjacent means beside, and this is beside our given angle. Okay, or beside the angle we're talking about. Now we want to find that angle. And we're given the opposite side, and we want to find the hypotenuse. Right? So opposite, hypotenuse, that's the sine ratio. So I'm going to use the sine ratio. The sine of theta is equal to the opposite over the hypotenuse. All right, then we're going to fill in what we know. So the sine of theta, we don't know theta. The opposite is 18.8 decimeters. I'm just going to write 18.8 divided by the hypotenuse, 19.83. Okay, we want to get the sine, the theta alone. So to get rid of the sine, I'm going to take the inverse sine of both sides. Okay, so I'm going to write this out. You don't need to write this step out. But the inverse sine is the opposite of sine. And we're going to be just left with theta. Okay, so I'm doing this to both sides. 18.8 divided by 19.83. Okay, and so what's going to happen is the inverse sine and the sine kind of cancel each other out. So it's the opposite of taking the sine, okay, the opposite step. So I'm left with theta is equal to the inverse sine. Okay, on some calculators this is a sine of 18.8 divided by 19.83, like that. All right, so it's handy dandy calculator time. So 18.8 divided by 19.83 equals, and then I take the inverse sine. So second, and see, sine of -1, click on that. So it's 71.4522 degrees. I'm going to round it to 3 decimal places, 4 decimal places. So theta is 71.452, and the 7 tells the 1 to round up to a 2 degrees if I was going to 4 decimal places. All right, so back into the program. So 71.4522, and then degree symbol. Okay, which is right there, degree symbol. And let's check to see if we're correct by clicking the check button, which is right here. Excellent. All right, level 8. So once again, I'm just going to rotate this by using the rotation gesture. 2 fingers, rotate. So this is our right angle. Opposite the right angle is the hypotenuse. It's the longest side of the right angle triangle. It's also the side that does not touch the right angle. Okay, so this is the hypotenuse. I'm just going to label that. All right, and then opposite our angle, the angle that we're looking to find, opposite our angle is the opposite side. Okay, so our two legs are the opposite and the adjacent. So this leg is the opposite. and the other leg would have to be the adjacent. Now remember, adjacent means beside, and it's beside the angle that we're talking about. Okay, the hypotenuse is also beside, so the adjacent is the side that's not the hypotenuse, that's beside the angle. All right, so we're given the adjacent and we're given the hypotenuse. Now adjacent over hypotenuse is our cosine ratio, so that's what we're going to use to solve this. So we're going to write cosine of theta is equal to the adjacent divided by the hypotenuse. Okay, and let's fill in what we know. Well, we don't know theta, so cosine of theta is equal to the adjacent, which is 2.7 millimeters, divided by 13.87, hectometers. And I'm not going to bother writing the units. Now I want to get the theta alone, so I'm going to use the inverse cosine. Okay, it looks like this. You don't have to write this step out. Okay, so the inverse cosine of the cosine, okay, what it does the opposite of finding the cosine, so you're just left with theta. Okay, so those two will cancel. But on the right-hand side, we're also going to be taking the inverse cosine of our 2.7 divided by our 13.87. All right, so these two are going to totally cancel. So and we're left with theta. Okay, so this is a step that we can think about. You don't necessarily have to write it. You can write it, of course, if you want. So I'm just going to put a little cloud around that. So that's something we think about, but we don't actually have to do. All right, next step. So we end up with this step, and this is important. Theta is the inverse cosine of 2.7 divided by 13.87. All right, handy dandy calculator time. So 2.7 divided by 13.87 is equal to, and then we're going to use our inverse cos right here. And that gives us 78.77 degrees. Doesn't that look like 78 degrees, 79 degrees? Okay. And just because of the sensitivity of the program, I'm going to round that to 3 or 4 decimal places. So theta is 78.77. Let's go with 3. Let's see if it likes that. 775. Now notice I'm rounding. I don't just chop it off. Okay. The program's looking for a percent difference between your answer and its answer. Okay, it'll accept some rounding error, but not a lot. Okay, so that's why I always round to 3 or 4 decimal places. All right, so I want to now go back to the program and see if we're right. So I enter my value, 78.775 degrees, and we click on the check button to check to see if we're right, and yes, we are. Use my rotation gesture, 2 fingers, and rotate to rotate it, and then maybe stretch it out a little bit. This is my right angle. Opposite the right angle is the hypotenuse. It is the longest side of the triangle. It's also the only side that doesn't contain the right angle. So I'm just going to label that hypotenuse. All right, and opposite the angle we're talking about, if we walk away from it, it's the first side we smack into. This is the opposite side. Okay, so the legs are the opposite and the adjacent. So this is my opposite side, and the remaining leg is the adjacent. Okay, remember adjacent means beside. It's found beside the angle. Okay, it's found beside our theta, the angle we're talking about. And so is the hypotenuse, but the adjacent is not the hypotenuse. All right, so if you label, you can't have the hypotenuse also be the adjacent, because the adjacent is supposed to be one of the legs. And the legs are perpendicular to each other. All right, so I want to find theta, and what am I given? I'm given the opposite and adjacent, and opposite and adjacent make our tangent ratio. So I'm going to use the tangent ratio. So tangent of theta is equal to the opposite side divided by our adjacent side. All right, so let's just fill in what we know. So tangent, we don't know what theta is, so I'm going to keep that as the theta. The opposite is 29.9 centimeters. And the adjacent side is 131 centimeters. No, is 13.1 centimeters. All right, now to get the theta alone, I'm going to take the inverse tan, which looks like this. So tan of -1 of tan of theta. Okay, and they're going to totally cancel. All right, so that's going to cancel with that. So the tan of theta goes one direction, the opposite, the inverse tan goes the other direction, so you're just left with theta. All right, and we're taking the inverse tan of our 29.9 over 13.1. So tan of -1 of our 29.9 divided by 13.1. Okay, and this is a step that you don't necessarily have to write down. Okay, this is something that we think about, but you don't really have to write it. All right, so the next step you do have to write, it's very important. We get theta is equal to the inverse tan of 29.9 divided by 13.1. All right, and handy dandy calculator time. So 29.9 divided by 13.1 is equal to 2.2824, and I'm going to take my inverse tangent of that, and that gives us 66.34 degrees. .340 degrees.